let's talk about gas sensor mounting heights and coverage areas. The purpose of this webinar today is to hopefully clear up some confusion about gas sensor mounting heights and placements and coverage areas. Different manufacturers in the industry have different recommendations regarding mounting heights, and so that leads to there being a lot of questions. And it's one of the most commonly asked questions that we get here at ACI is, where should these sensors be mounted on the wall, and how many sensors do I need to cover a certain space? Please note that any of the recommendations that we provide, they should be secondary to any local building codes or specific job requirements. To the best of our knowledge, there aren't any national OSHA standards or ASHRAE standards when it comes to gas sensor mounting height. So what we're recommending today and what we'll talk about is our recommendations based on best practices, and that they should always be subsidiary or secondary to any local building codes or specific job requirements that you may have. We base our gas sensor mounting height recommendations on the specific chemical weight or density of that gas. There are certain gases that are lighter than air, certain gases that are more or less neutral or the same weight or density as the ambient air, and then there are some gases that are heavier than the ambient air and will sink to the floor. Some examples of these lighter than air gases are helium, ammonia, hydrogen, natural gas, methane, and because these are lighter or less dense than the ambient air, they will rise to the ceiling of a certain space. And so for those sensors, we would recommend you mounting that unit as high towards the ceiling as possible. Generally, that's 6 to 18 inches below the ceiling. Some gases are more or less neutral to the ambient air, like carbon monoxide, carbon dioxide, nitrogen, hydrogen chloride. In those gases, we will recommend mounting what we call the breathing zone, which is 4 to 6 feet from the floor. And then the heavier than air gases like chlorine, nitrogen dioxide, propane, butane, and pretty much all types of freon refrigerants are heavier than the ambient air, so they will sink to the floor. And so for those gases, we would recommend those being mounted as close to the floor as possible, anywhere from 6 to 18 inches above the floor. That's the general recommendation. We look at the specific density of the gas, because in any certain space, that gas will either rise to the ceiling, sink to the floor, or be more or less neutral to the ambient air. So in most applications, that's where we're going to recommend mounting that sensor, is specifically based on the chemical weight or density of that gas. However, there are certain applications that we come across pretty regularly where you might want to mount a sensor in a different spot than what's based on the chemical density of that particular gas. And we'll discuss that right now. For NO2 gas, or nitrogen dioxide specifically, it's present in diesel exhaust. So we're seeing requirements for parking garages, bus garages, loading docks, fire stations, bus stations, where you have to monitor both CO gas, carbon monoxide, and NO2, nitrogen dioxide. So in those applications where you might have a high stack exhaust, like you see in the semi pictured here on your screen, where that gas is going to be exhausted up high towards the ceiling. So in these applications, we would recommend mounting an NO2 sensor high towards the ceiling, because the gas is first going to be exhausted high out of this stack, and because it's hot, it will rise to the ceiling. So a sensor mounted up high will give you the first chance, or the best chance, of detecting that gas immediately upon its exhaust into the space, and allow you to turn that fan on and exhaust that gas from the space before it would get to the breathing level. So in these cases, we would also then recommend mounting a second sensor in that breathing zone. So any gas that is missed by this first sensor or cools and sinks quickly, it would be detected as it enters the breathing zone to give you another added layer of protection. So this is one example where we would deviate from the specific chemical density mounting height recommendation. Moving on to the placement of gas sensors, depending on the specific sensing element, the type of sensor that's being used, as well as the specific gas being sensed, Most gas sensors have an approximate coverage area of either 5,000 or 7,500 square feet. We recommend that you mount the sensor in the middle of that circle, if you will, in order to maximize the coverage area. A 5,000 square foot circle will have a radius of about 39 feet, and a 7,500 square foot circle will have a radius of about 50 feet. Some other variables will go into consideration when determining gas sensor placement and coverage areas, and those are the characteristics of the gas. Like a very heavy gas like a Freon, it's not going to disperse and fill the space as quickly as a lighter gas like hydrogen or helium. The overall airflow in the space, if it's a garage with multiple entrances and exits and multiple windows or vents, you may need fewer sensors to cover that space. There's also like an underground parking garage where you have pillars or low ceilings and limited entrances. You might need more sensors to cover that space. We recommend that the sensors be placed so that they would slightly overlap to eliminate what we would call dead zones, any areas in a space that gas could accumulate without being sensed. So we want to overlap slightly and also have the sensors placed in a central area as possible, not only to get the best coverage, but to minimize the number of sensors that you would need and therefore save you money in terms of the total cost of the installation of these gas sensors. Moving on to refrigerants. You can use one sensor to cover multiple chillers, assuming that the chiller uses, or each chiller uses the same type of refrigerant. So in the drawing on your screen, we would have one QIRF refrigerant sensor or monitor mounted towards the floor because it's a very heavy gas in between these two chillers. So you don't necessarily have to have a separate sensor for each chiller as long as those would have using the same refrigerants, and that the overall space would be less than 7,500 square feet. An application that we're seeing more and more regularly in the recent years is the use of hydrogen sensors in battery charging areas or for like server backups, golf carts, electric cars, because these are typically wet cell batteries or lead acid type batteries, and they give off hydrogen as part of the chemical reaction that occurs when the batteries are charging. So in these applications, the hydrogen is lighter than ambient air and will rise to the ceiling, and if the levels build up enough, it could be potentially combustible. So we recommend using a 0 to 100% LEL measurement that would measure from 0 hydrogen in the air all the way up to 100% of the lower explosive limit. That gives you the best coverage and the best detection without short cycling your system and starting your fans too often and wasting energy. There are a number of hydrogen sensors available that have much lower ranges. For example, 0 to 1,000 or 0 to 2,000 parts per million. And if you use one of those sensors, because those ranges are so low, they're going to be short cycling your system and you're going to waste energy unnecessarily. Lastly, today, we're going to talk about the calibration intervals for these sensors. All of our toxic and combustible gas sensors should be calibrated on a yearly basis, and that's again in absence of any specific job requirements or building codes that would require a more frequent calibration. These sensors should be bump tested to verify their functionality and accuracy about every 6 months for toxic gases and about every 3 months for combustible gases. All of the calibration information and documentation can be found on our website, which is workaci.com. We also have this handy cheat sheet available on our website, which shows the recommended mounting heights and coverage areas for all of the gas sensors that we provide. And what's shown here is the most common of the gases. We do have sensors that can detect a number of other types of toxic and combustible gases that aren't shown here, and we're happy to help you with placement and recommended mounting heights for any types of gas sensors that we provide. So with that, we're going to move on to the Q&A portion of the webinar. I'd like to point out our contact information that you see on this screen. Both Dave Wisey from our tech support team and myself are available to answer any questions that you may have. Our info is on the screen. Also, I'll point out the live chat function on our website. That's available anytime that our office is open, and you can get an immediate response from technical support with any questions that you may have. Let's move on and answer some questions. The first question that has come up is, does ACI supply calibration kit? The short answer is no. We supply calibration adapters that attach to the sensors that then you would want to hook up to a separate gas regulator. We don't supply the regulator or the calibration gas. For the main reason that we don't is because it's expensive to ship, and so we would have to, you'd have to pay to ship it twice. If we would bring it into our facility and then ship it back out to customers, it's not competitive for us to do that. So we recommend either going to a local like welding supply company where you can get the known quantities of the calibration gas as well as the zero gas, or we use an online resource called Mesa Gas where you can buy the calibration gas, the zero gas, as well as the regulators. We do recommend using a 0.5 liter per minute regulator to apply the correct amount of gas to the sensor for calibration, and that's available via Mesa Gas as well. Another question that we have here is, if CO and NO2 can both be mounted in the breathing range, do you offer a sensor with dual sensors, or a detector with dual sensors? As of right now, we do not have a dual sensor, and I'll go into some information on why not. We have seen some combination sensors that are available in the marketplace, specifically combination CO and NO2 sensors that are in one enclosure that can be mounted at the same height. These are developed simply as a cost-saving solution, and it's not always a best practice to mount CO and NO2 sensors at the same height. As we mentioned before, NO2 is heavier than ambient air, so if it's in a parking garage where it's coming in vehicle exhaust, that gas is going to stay low to the floor. And so if you have a certain gas mounted or a certain gas sensor mounted at breathing zone, you might not get the early detection that is needed to exhaust the space of these toxic gases. We do have in development a sensor that is, call it a remote sensor. So there would be one main panel or main sensor, and then you can run wire to a remote sensor. And this is going to be a little lower cost than the existing dual sensor, but we're still going to have the remote sensors mounted at the correct height for that specific gas density. In few cases do we recommend mounting CO and NO2 sensors at the same height. And like I mentioned, that was developed as a cost-saving mechanism. We would encourage you to reach out to us because while the mounting two sensors may not be as cost-effective as mounting a combination sensor, ACI can provide project pricing, and ACI does have a full line of sensors, beyond gas. So temperature, humidity, pressure, current, interface, wireless. So we can provide a competitive quote or competitive price across your entire job, not just on the gas sensor application or the gas sensor side of it. So I encourage you to reach out to us for project pricing. We can be very competitive for you. Another question along those similar lines, why do some sensor manufacturers recommend mounting NO2 sensors in the breathing zone? That's simply generally as a cost-saving mechanism for ease of install, because there's, like I mentioned at the start of the presentation, there's no national OSHA or ASHRAE code for sensor mounting heights. So sometimes people just recommend putting everything in the breathing zone because that's where people are breathing. And I understand why that recommendation would be there. However, again, we recommend mounting the sensors without any building codes or specific requirements to mount the sensors based on the actual chemical density of that gas or the density or chemical weight of that gas, because that's where that gas is going to pool and build up, and you're going to have the highest concentrations of these toxic or combustible gases. Next question is, does ACI offer a solution for monitoring toxic or combustible gases in ducts? Yes, we do. We do have a duct adapter that is available for any of our toxic or combustible gases. It's a simple adapter that has a probe that plunges into the duct that connects to the sensor. So the probe will sample the gas from the duct and bring it to the sensor, where the sensor would be mounted on the outside of the duct for easy calibration and maintenance. And so it's just a simple accessory that can hook up to the sensors. Another question is it code anywhere to mount NO2 wherever you mount CO? And I don't know. I've never seen a specific code or requirement to mount all of these sensors at the same height. That may be, but I'm not familiar with any a specific code that calls out mounting every sensor at the same height. Again, we'd like to thank you all for joining us today. This will be archived and put up on our website shortly. So if there are additional questions, feel free to reach out to us with the contact information that is on the screen, and stay tuned for upcoming installments in our educational webinar series. Thanks again for joining us. Look forward to talking with you soon. Have a great day.